Hi, this is for geometry. This is for Tuesday's lesson. Reflections. The first one we learned about was translation. So they're moving this many units up, this many units down. Reflection is if I were to draw a heart on the piece of paper and were to fold it exactly in half where that line crosses, that means each of the side of the heart will touch at both sides. So reflection, think of a mirror. So it looks just like on the other side of the mirror. It's exactly the same. So there's a couple ways we can work this. There's like the mathematical way, or there's the way that you have to draw it out. Both ways work out if you really don't like it that way. But let's do the mathematical way. For your homework assignment, make sure you're actually writing down the coordinates. So I have them there for you how I want you to write them out, and you need to write them out with the proper name to them. Here, if it's a reflection on the x-axis is considered this bottom line here. So if it's a reflection on the x-axis, you have your normal coordinate, x comma y. All you do is change the y to be a negative. If it's a reflection on the y-axis, so it's a line up here, you have your regular set of coordinates. All you do is make x a negative, or just opposite signs for the x, but y stays the same. So now, here, example 1, we have a triangle here. They want a reflection on the y-axis. So that means what we're focusing on is this one right here. So txy is equal to x being an opposite sign and y staying the same. So here, if I have a, x will be opposite sign. So it's negative, -7, comma, and y stays the same. And that turns into 7, comma, 6. Positive 7, comma 6. Next one, b. So we make the x negative, so it's going to be negative, -2. Y stays the same. We get b as being positive 2 and 3. C, last one. So it's a reflection on the y-axis. So like imagine you folding this whole graph in half, and it's going to touch exactly at the same points. So you make the x negative, and the x was already negative, so you do opposite signs. So then you get 7, 1. Now if you were to graph these, so let's say we want to graph these to make sure they are actually a reflection. So A is 7, 6, that's right here. B is 2, 3. And C is 7, 1. And we end up with a graph looks like that. I made it smaller here because of the room, but this will be considered reflection, exactly the same distance from the y distance from every point, and therefore it's reflection. Example 2, we want a reflection where y equals 4. I drew this out here on my grid here because it's a little bit different. Sorry, it's dirty. You can't apply those rules here to this shape here because of the fact that they create the line that they want the reflection on. Here it says to reflect where y is equal to 4. When you're creating a line that's y equals 4, you're creating a line that crosses at 4, and that's 4 units here, and that's where that red line is. Here is the usual coordinates, and I have that up here as what they have on the pictures. So I identified them here. They want a reflection on y equals 4, so they want this, imagine it being flipped and moving it down here. So what a reflection is, it's the same number of distance away from that line that they're asking you to reflect from. So here, let's look at V. Let's look at V here. So from this distance to the y equals 4, it's a distance of 2 units away. So if it's 2 units away here, it's going to have to be 2 units away here. So it moves down a total of 4 units away. So it has to be the same number of distance from the line here. So that's 2 units. That means I have to do 2 units on that side as well. And I get V. U, it's 2 units away. 1, 2. So that means the reflection would be 2 units away as well. So that means it's going to equal 4 units in total. So I have my U. Here I have my S. So I have to count from the y equals 0. So the number of units. So 1, 2, 3, 4. So this is 4 units away. So if it's 4 units away from one way, it has to be 4 units away from the other way. So it's 1, 2, 3, 4. And it's right here at this line. And that's your new S. T, same thing. So it's 4 units away. 1, 2, 3, 4 away from here. It has to be 4 units away the opposite direction as well. 1, 2, 3, 4. And you have T as being not right there. It's just right here. You just can't see it from there. So it's a reflection. It's exactly the same way. It's just moving shifting downward. So you end up with a graph like that, and those coordinates is going to be your new set of coordinates. But it's different because of the fact that the line is not, it's not the x-axis anymore, it's not the y-axis anymore, so that therefore you have to draw it out. So here, so the reflection. So when I reflected, I ended up with, so S is -2, 0. It was 8 units down from there. T was 2, 0. U was 2, 2. And then V was -2, 2. But again, you have to draw it out to see what it looks like, and it's exactly a shift. It's exactly the same number of units away from the line on both sides. All right. Example 3. So now we have the basic formula here. So now they're going to create a line, and they want you to reflect from that line. So let's say reflect on y equals x. That means it's a standard line. That means when you have your x, y, you're going to flip the two coordinates. And if it's a reflection on y equals -x, so that means your line's facing the opposite direction. Your coordinates, they're going to be opposite, but they're both going to be a negative. So they're both going to be opposite signs. Now here, we have J. So we have -3, 5. And example 3, they're asking for a reflection on the reflect on y equals x. So the one that we're going to focus on is this top one right here. So reflection on y equals x. According to that, for a reflection on that line y equals x, all you do is simply just flip the two numbers. So it's -3, 5. That means my new coordinate is 5, -3. K, it used to be 0, 8. You flip it. Now it's going to be 8, 0. L, it used to be 3, 5. Now it's going to be 5, 3. And last one, 0, 1. Now it's turning into 1, 0. And if you don't know, if you're unsure if it makes sense, go ahead and plot it right here. 4, 5, 1, 2, 3. This is J. 8, 0. 5, 6, 7, 8, 0. That's K. L is 5, 3. 1, 2, 3, 4, 5. Oh, -3. 1, 2, 3. J is here, and this is K. L. So L is 5, 3. So that's up here. And then J was 5, -3. So that's down here. And then M is 1, 0. So it's 1 and it's 0 here. And it creates a graph like this. And it's a reflection on that line right there that I drew right there. So you can draw it out to see if it makes sense. The last one here is, it's a word problem. So we have some type of weird triangle, and at like the bottom of the triangle, it's this weird shape over here. So they want this triangle, they want a reflection on where y is equal to 2. So what I did, I went ahead and drew my dotted lines for y is equal to 2. So from the 3 coordinates here, I'll label them A, B, C. So this is A, 2, 8, this is B, and this is C here. They want a reflection on y is equal to 2, and that's where we have to go ahead and count each spaces away. So here, from this space from A, from the number of units away from y equals 2, there is actually no units that it's away. So here, the distance from y equals 2, it's on that line already, so that means the distance does not change. So new A is still regular A. Let's do the same thing on the other side. So it's on 10, 2, so it's on that y equal 2 line. So if it's a reflection, it's not going to move at all. So that means your C, your new C, still stays the same. So now what does matter is your B. So B was 2, 8. Now we have to count the number of units away from that y equals 2 line. So that's 1, 2, 3, 4, 5, and 6. This from here to here is 6 units away. So that means when I'm counting, it has to be 6 units away from the other side as well. And that would be, I drew this line very bad, and that would be at -4. So they stay at the same, so at 2, -4, and then your new B is going to be 2 and then -4. So it's a reflection on the y-axis. That means you're just counting the number of units down. So it's 6 units here, so that means here it has to be 6 units as well, and that's where I got -4 here. So that means my new coordinate for B will be 2, -4, and these will be my new coordinates for reflection on the y equals 2. But if it was just a regular y-axis or x-axis, you just put negatives. That's all it means. If you have any more questions, make sure you go down there. Make sure you're doing the homework assignment daily. You're not going to be able to make these homework up. So once you haven't done it, it goes back to being 0. Bye-bye.